who have been launched in the space. That is Sputnik 1 in the year 1957. The first person to have traveled to the space was Yuri Gagarin, who was from Soviet Union, today called as Russia, right? He was the first person to have went to space. And who was the first person to have went to the moon, to have landed on the moon? Everyone knows. That is, isn't that obvious? The first person to have landed on the moon.
So what's the question?
The first person who landed on the moon.
Neil Armstrong.
Neil Armstrong, exactly. Right. Then we did learn about the celestial bodies. So we know that our universe is so vast, it is beyond measurement, beyond our visualization, right? And it contains lots of objects like stars, planets, galaxies, whose size is unknown. The universe is expanding, and everything in the universe, its size and their numbers is unknown. So when we talk about all these things, including when we include stars, planets, and galaxies all together, so it is basically part. These are basically called as celestial bodies, right?
Yes, sir.
So other than the bigger celestial bodies, we have some tiny celestial bodies also, like meteors, meteoroids, asteroids, comets, etc. We learned about astronomy. It's the field basically where we study about the celestial bodies and the different phenomena that are associated with them. Further, we learned about the only natural satellite of the Earth, that is the moon. Okay. Further, we learned how does the sorry, how the moon would be doing rotation as well as revolution around the sun, and it takes roughly about 27.3 days to do this. Getting it now? We have learned about that. Then we did also learn about the different phases of the moon and the surface of the moon. Also, we have learned that, right? Also, we see that we are only able to look at one side of the moon and not the other side of the moon. The reason behind this is that the time taken by the moon for rotation and revolution around the earth is approximately same, because of which we always observe the same face of the moon from the earth. Other face remains hidden from the earth. Getting it?
Yes, sir.
If you were to visualize it now, you will be able to understand it more specifically. Okay, that is one thing. Further, lots of craters are there on the surface of the moon. Getting it? Further, we did learn about the comparison between the mass and weight. You can just give me 1 minute. I just need to take some warm water, so I will be able to speak smoothly. Okay, just 1 minute. Okay. Meanwhile, you guys know 1 minute. Revise the different phases of the moon. Okay, no? Just go through this. I will be back in just 1 minute. Yes, I'm back. Like every winter, I have this problem. Like if I were to speak for too long, then I get problem in the throat. Yeah. Okay, so we were learning about this. Okay, Chakrika, you have this question that why? Okay, like why there are craters on the moon? Okay, see. Basically, over the course of lakhs and lakhs of years, probably millions of years, Okay, lots of asteroids, lots of comets have been falling onto the surface of the moon. So because of the collision of the asteroids and the comets on the moon, so these roughly circular shapes called as craters have been created on the moon. Getting it, guys? So that is the reason. Okay, no? Okay. So it has been basically due to the impact of the asteroids and the comets. Hope that answers the question. Further, we did learn about this thing about mass and weight as well. Like mass is the original composition, how much of matter an object contains. That is going to remain same everywhere. Whether you are on the equator, you go to the pole, or you go to any celestial body, your mass is going to be same. But the weight is going to change because the weight is not constant. It changes from place to place as the gravity would be changing. You guys should know that when you are standing on the pole, so you experience more gravity in comparison to the equator, because when you are standing at the pole you are more closer to the center of the earth, as you would be aware that our earth is roughly spherical. It's like oval in shape. Okay, roughly oval and roughly spherical in shape. Okay, talking about the weight, I they told you that if someone weighs 90 kilogram on earth, so the weight of that person becomes 1/6 on moon, so that is 15 kilogram. So you would have observed that the astronauts who went to the moon, so they would be jumping, they would be hopping onto the surface of the moon. Okay. Then obviously we can't hear the sound on the moon because there is vacuum and sound requires particles of the medium to propagate its energy. We learned about this interesting thing about the space suit and stuff like that. Why they are different colors. Basically, when they would be returning back to the earth, they would be wearing this suit so that if they were to fall onto the oceans, they will be easily identifiable from a distance. Further, we learned about the lunar eclipse. So what happens on the lunar eclipse? Earth casts shadow on the moon when it comes in between the moon and the sun. Getting it? That is what happens here. And as a result of the revolution of the moon around this earth, okay, different phases of the moons are produced like this. So we have learned about the new moon. Okay, when most of the sunlight, when it will be receiving more insolation, more sunlight will be falling onto the new moon, right? Sorry, I mean to say when one side of the moon would be receiving the sunlight, the other side of the moon will not be visible. Getting it? So thereby new moon is created. Then slowly what happens, the area of the moon that is illuminated by the sunlight goes on to increase. So thereby different phases of the moon are created, which we have discussed. Like this, you'd be seeing the different phases of the moon. So you guys tell me the different phases of the moon last for about 28 days or for 29 days or for 29 and a half days. Tell me. You guys getting the question?
28 days.
No, it's not 28 days. It is 29 and half days. Getting it? It is 29 and half days. Keep that thing in mind.
Okay, sir.
Okay. Also, there is this phenomena called as the blue moon. Okay, ever heard about this blue moon? Like any idea what is blue moon? Ever heard of this? Anyone? See, since we are seeing that the lunar cycle, the complete cycle of the moon takes about 29 and a half days. So sometimes two full moons can happen in 1 month, which is very rare, It's not like you will be seeing two moons in the same night. Getting what I'm trying to say? It's not like you look into the sky and you see two moons in the sky. No. Okay. There will be two full moons in 1 month. Getting it? So that is phenomena is basically called as blue moon. It's not like the moon becomes blue on that day. It's basically a term that we're using to describe this event that is very much rare. Further, we learned that there are various festivals also in India which are marked with the different phases of the moon, like Diwali celebrated on new moon day, Guru Nanak's birthday celebrated on the full moon day, right? Mahashivratri celebrated on the 13th night of the waning moon. Getting it? On the 39th of the waning moon. And Eid, that is on the day following the crescent. These things we have discussed further. I did told you that there are various accidents that have occurred in the space, and it is it also occurs basically. And what will happen to the body? Those things we have discussed. Now let's continue our discussion from here. Now, stars are the celestial bodies that comprises of hot gases. They are mainly made up of helium and hydrogen. And nuclear reactions are occurring in the core of the star, because of which they would be emitting heat and light. And since they are emitting their own light, they are the luminous body. Further, all the stars are not of the same size. They vary in color, they vary in the size, in the shape as well, and they produces varying amount of heat. So thereby temperature of different stars is also different. That is one thing we have learned. Plus the stars should be appearing very tiny to us because they are at a huge distance from the surface of the earth. Okay. Now stars also have a life period. They take millions of years to born. They will be living for millions of years or billions of years. Yeah, stars also have different colors, Chakrika, and that is because of the temperature. Okay, different stars would be producing different temperature. Because of that, they'll be giving out different colors. It's not like some of them would be giving blue, or some of them will be giving a different color, like different color or green, like not like that. It will be varying color. Okay, like it would be light orange, light yellow, dark orange, kind of like that. Okay. Further, we see that due to the long lifespan of the stars, various changes are occurring, and the changes are not very sudden. Like if you were to look at the sun, so there's a spot on the sun also. There's a spot on the sun also, which is basically a storm. Getting it? So you might have seen the sun spots. Just like there are spots on the moon, so there are sun spots also. Dark spots that you see on the surface of the sun, they are sun spots. Okay, that is one thing. So earlier it was believed that the star that is our own star, that is the sun, it is not moving, it is not doing rotation, but it was observed that it does rotation also. So basically there's a giant storm on the sun. So when the position of the storm on the sun was observed, so it was shifting its position. So due to the shifting in the position of the storm on the sun, it was concluded that the sun is also doing rotation on its axis. That is one thing. Further, we know that the stars will be twinkling. It appears to be twinkling because the rays of the light that are coming to the Earth are traveling lakhs and millions of millions of kilometers of distance. So thereby, the rays of light, when it enters into the atmosphere, it bends, and because of which the stars will appear to be twinkling.
Sir, can you explain it again?
Which one? This twinkling of a star.
Yes, sir.
Yeah. See, basically what happens, say that this is any star. For example, it is several millions of kilometers away from the Earth. When the rays of light will be entering into the atmosphere, like say this is the atmosphere of the Earth, so the rays of light will be bending. See, this is the incoming ray of light, it is bending. And that one is the, by the way, actual position of the star. Okay. And this is the image of the star that is being produced. Sometime it is produced over here, sometime it is produced over here. So because of which it gives a twinkling effect. Getting it, guys? So light is traveling as it will be bending to onto the, as it will bend when it goes into the atmosphere of the Earth. It will travel in a zigzag way. Okay, no? So thereby, because of that, the rays of light, um, because of that, we will see that the apparent position of the star would be this. That would be the apparent position. It will appear as if the star is sometime here. 1 minute. It will appear as if the sometime the star is over here, sometime it is over here, because of the refraction of the rays of light. So as we know that, as the rays of light will be traveling through the different layers of the atmosphere, like you have troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Huh? All of them have got different densities. Getting it? So suppose that this is the atmosphere, and these are the different layers of the atmosphere. Suppose so, you have got troposphere, stratosphere, mesosphere, thermosphere, exosphere, like this. Exosphere, and then you have ionosphere. Now, as the rays of light are passing through it, so it has got different density, right? So the rays of light will travel in a zigzag motion like this. Getting it? So because of which the image of the star, which is star is suppose over here, but the image of the star is sometime being produced over here, sometime it is being produced over here. Getting it? When it is viewed by the
Yes, sir.
observer on the Earth, and hence it appears to be twinkling. Further, the sun is also a star because it meets all the definition of a star. It has a lifespan, it can produce heat and light on its own, right? It is our sun is born about it was born about 5 billion years ago and will last for next 5 billion years. That is one thing. Further, we know that the distance between the sun and the earth is very huge, right? So how what is the distance between the earth and the sun? So this is the distance here. Okay, that is how much?
150 million kilometers away.
Exactly. Okay, so that's the distance. Now the star that is closer to the earth after the sun, that is Alpha Centauri. So right after the sun, the next star closest to the earth, that is Alpha Centauri. That is at a distance of about this much of kilometer. Getting it? So that is how much?
40 trillion.
40 trillion, exactly. So that's the distance. Further, we had this concept of the light year. So light year basically tells us the distance traveled by the light in 1 year. How much of light, for example, this is a star that is emitting out light, and the distance that would be traveled by this light in a span of 1 year, that in simple terms is being called as light year. Getting it? Also, we know that the speed of light is about 3 lakh kilometer per second. So in just 1 second, it travels 3 lakh of kilometers. So just imagine in 1 year how much of distance it would be traveling. That is one thing. Also, the distance between the sun and the earth is 8 light minutes. Why? Because the sunlight takes roughly 8 minutes and 20 seconds to reach from the sun to the earth. Thereby, in terms of light year, it is 8 light minutes. Getting it, everyone, what I'm trying to say?
Yeah.
While the distance between the Alpha Centauri and the Earth in terms of light year, that is 4.3 light years approximately. Okay. Further, the question is like why the stars are invisible during the daytime? Because the stars present in the sky during the day as well. Like the stars are always present, right? But during the day, they are invisible because the sunlight is so bright that it becomes difficult for us to look at the stars in the sky. Okay. Then talking about the Proxima Centauri, right? You might have heard of this, I suppose, right? Okay. So this star was first discovered in the year 1915 by this person named Robert Innes. Okay, and it's the nearest known star to the sun. If you were to talk about like which star is nearest to the sun, so that's the Proxima Centauri. That's the Proxima Centauri. Getting it, everyone? You might be having this question that how is Proxima Centauri different from Alpha Centauri? Yeah, like how is it different? So Proxima Centauri, I'm saying we are saying that this is closest to the sun right now. This is the closest star to the sun. Also, Proxima Centauri, it's closer star to the Earth, while Alpha Centauri, we are seeing that it's a star that it's a system of stars basically. Getting it? And in that you have got this. We have got the Proxima Centauri as well. Okay. So Proxima Centauri is the closest star to the Earth, while Alpha Centauri, it basically refers to a system of stars, like it contains 3 stars in it. Okay. And out of that, Proxima Centauri is the closest out of all that stars. Getting it? That is one thing. Then talking about the pole star. So pole star is the star. So do not break apart when they get too close to the. See, like stars, like Chakri has asked this question, sir, do the stars explode or break apart when they get too close to the sun? See, every star has their own field of gravity. Getting it? Every one of them have their own field of gravity. And also the bigger the star, higher will be its force of gravity. Higher will be its gravity. Getting it? So a star that has more gravity, okay, it will be pulling the star that has less gravity. Sometime if it happens that a star of a small size way to come towards a star that has more gravity. So obviously the smaller star will go towards the bigger star. Also, to answer this question, like whether they explode or break apart, so stars do not explode or break apart when they get too close to the sun, because the distance between stars are so vast that even if a star were to pass close to the sun, the gravitational influence in this situation we see that will be almost, I think it would be almost negligible. Getting it? Instead, what happens now? The stars would be exploding or would be basically collapsing at the end of their life period. Getting it? Basically, what happens? The nuclear fuel basically would be running out, and that is called a supernova. Have you guys seen the supernova? You might have seen the images of supernova, I suppose. So that happens. So generally the stars are like very far away from one another, so it is very less likely that one star would be colliding into another. Okay, getting back to this star, that is the pole star. So it is directly above the Earth's north pole in the sky, and it is one such star that appears to be stationary irrespective of the rotation of the Earth. And because of this, it has been used in navigation also. It has been helpful in navigation throughout the history. Okay, that is one thing. So sailors would have been taking the help of the pole star. Okay, also called as the north star. Okay. Then talking about the constellation, which is basically group of stars, right? So group of stars which are arranged in a pattern that would be resembling some recognizable figure, that is basically being referred to as constellation. Note down that they are not bounded, or like they're not connected via some physical structure or physical means. It just appears to us as some patterns, right? There are about 88 constellations that we know so far. All the stars in the constellation appear to stay together, so its shape remains the same. Four of the well-known constellations are Orion, Ursa Major, Ursa Minor, and Cassiopeia. Getting it? That is one thing. So all the stars would be appearing to stay together. Okay, now they will be not moving very farther away from one another. Like they are at a fixed distance from one another. That is one thing. So you can take a look at some of the stars over here. Okay, constellations, I mean to say. You must have heard of astrology. Huh? So we see that
Yes.
astrology and the star constellations are very much linked together, right? So they are deeply connected, like as the constellations forms the basis of the zodiac signs here, right? So they're like the 12 constellations that lines up over here along the sun's path. Okay, these are as follows. Getting it now? So you have Aries, you have Taurus, Cancer, Leo, Virgo, Scorpio, Aquarius, etc. Getting it? So that is the case. So the constellations forms the basis of this. Okay, and throughout the history, we see that constellations were used to track the movement of the sun and track the time also. Getting it, everyone so far? Let's talk about this Ursa Major, also called as the Great Bear or the Big Dipper, or in Sanskrit also called as Saptarishi, because it has got 7 stars in it. Okay, so it contains 7 stars, and that makes up the pattern of a plow. That makes up the pattern of the plow. That is one thing. Also, with the help of this Ursa Major, we'd be able to spot the position of the pole star also, or the also called as Polaris, or like in Hindi that we call as Dhruv Tara. Okay. So the pole star always appears in the same position in the sky as it is directly above the north pole of the Earth. Okay. Also, this Ursa Major is particularly visible during the summers when the sky is clear. Getting it? So that is the Ursa Major over here. Okay. When we are connecting this star, when we will be learning about this, like how with the help of the Ursa Major and the Ursa Minor, there's another constellation called as Ursa Minor, will be able to locate the pole star. Okay. So in order to locate it, okay, what we can do, first we'll be looking at the Big Dipper, that is also called as Ursa Major here, right? Basically, it will be appearing as a group of 7 stars in the sky, in the northern sky particularly. Okay. Now find two stars at the edge of this Big Dipper. Like this is resembling like a shape of a bowl. No, this part of the Ursa major represents the shape of a bowl, isn't it? Okay. Now look at these two stars. Look at these two stars at the edge of this bowl. These two are called as the pointer stars. Getting it, everyone? These two ones, like let me highlight it. This one over here and this one over here, they are called as the pointer stars. Okay. Now we are going to draw an imaginary line from these stars to locate the Polaris or the North Star. Getting it? That is one thing. Also, we will observe that there is another star called as Ursa Minor or also called as Little Bear, which we are going to learn in a minute. At the tail of this constellation, at the tail of this another constellation, the Polaris star would be present. So this imaginary line, it will be projected, it will be leading us towards this North Star. Getting it over here. So that's this one over here, right? So Ursa Minor, the Little Bear, is a constellation in the northern sky. Its most notable feature is the Polaris, that is the North Star, which is located at the tip of its tail. Getting it, everyone? So with the help of this major, Ursa Major, we are able to locate the Ursa Minor and as well as locate the position of the North Star. Tell me if that thing is clear. How we can spot it?
Yes, sir.
Getting it, everyone? So that is the case. Also, this Ursa Minor would be visible throughout the sky in the northern hemisphere, particularly. Hope this much have been clear so far. Okay. After this, there are some other constellations also, but usually these two are much important, and usually questions will be asked from these two. If time permits, we'll be looking back at these two stars later on. Okay. Next, let us quickly sum up the differences between the galaxy and the constellation, like how they are different from one another. As we know, galaxy comprises of stars, planets, comets, asteroids, gases, and dark matter, and all of them together are bounded together with the force of gravity. So that makes up the galaxy, right? So we have the Milky Way, Andromeda, Whirlpool galaxy. All of these are the examples of galaxy, and it contains billions to trillions of stars. And let me tell you one thing, that it is noted down that there is about 10 raised to the power 11 galaxies have been discovered so far. Just imagine how much of galaxies are out there in the universe. Opposite to this, we have constellation, which is merely a group of a star that resembles to us as some patterns, right now. That is one thing. And usually they are made, they named after some mythological gods, mythological figures, objects, or animals like that. So we have Ursa Major, Orion, and Leo. While they are not physically related, they are very far away from one another, and they are not physically connected. So that is the case. Hope that much should have been clear. Next, we are going to learn about the solar system. Okay. We have half an hour left now. Okay, so we'll be able to do this supposedly. Okay. So talking about the solar system, what do you guys understand by the solar system? What is it? It's basically a system in which
8 planets and the sun as well.
okay, and basically we see that not just planets, but whatever we see in this Milky Way, our solar system particularly, what we note down there, there's a system in which the planets, the moons, the comets, all of them are bounded together right now by the force of gravitation, right? So the solar system, it's a gravitationally bounded system that includes the sun, the planets, the moons, the asteroids, and some other objects. That is what the solar system is in simple terms. Getting it? Then
Yes,
there are
sir.
various planets in this which we are going to learn about. Okay, that is one thing. Okay. By the way, the spotting of the Polaris star, that is important. Make sure you guys revisit that after some time after the class. Okay, that is usually asked in the exam, like how you can spot it. Okay. So solar basically here means of the sun. The term solar here, SOLAR, solar basically means, its meaning is of the sun, right? So solar system is the sun and its family, basically its family of objects that would be revolving around it, right? And why all of
Sir,
them are. Mhm.
can you actually explain it again, like how to locate the pole star?
Okay. Okay, see one thing, let's do one thing. I'll be taking up that topic at the end of this. Okay, no, just 1 minute.
Okay, sir.
So solar means of the sun, right? So solar system is the sun and its family of objects that will be revolving around it, and all of them are revolving around the sun because the sun is the gigantic body present here, and its field of gravity is more. It is the powerful object. Its uh, field of gravity is more. So hence all the objects are revolving around it, right? That is one thing. And apart from the planets, and the moons, there are millions of smaller objects like asteroids, comets, and meteoroids that will also be revolving around the sun. So we can define the solar system, that the solar system basically consists of the sun, the 8 planets, their satellites, and millions of smaller celestial objects such as asteroids, comets, and meteoroids. Getting it? And the sun is at the center over here. It's at the center of the solar system, and all of the objects are revolving around it in an elliptical path that we are calling as orbit. So every object here has an orbit. Even a meteoroid has an orbit. Even a comet has an orbit. Getting it, everyone? These imaginary lines are called as an orbit. They are not physical lines. We have drawn it ourselves for convenience in understanding. Getting it so far, everyone? You guys understand the elliptical path? No? Elliptical path is something like this. Okay, not perfectly circular. So all of them are moving in the circular, in the elliptical path. Now you might have wondered, like, how exactly are the planets moving? Planets and the moons are moving around the sun. You might have been wondering that all of them are moving in this manner, like moving around the sun like this. But that is true. But the sun is also moving in the galaxy. No, sun is also doing revolutions. Just take a look at this video that will help you understand that how exactly the planets, the moons, and the sun is moving in the universe. Take a look at how the earth is moving, how the moon is moving around it, and look at how all the planets are moving around the sun. Just observe it. And the sun is itself also moving. The sun is basically moving around the Milky Way galaxy. Okay. So that's how the sun, along with its family, is moving in this manner. Got it, everyone?
Yes, sir.
Okay. Let's talk about the different planets now. Okay. So first, we are going to start with the closest planet. By the way, also make sure you memorize the order of the planets. The first planet from the sun is, it's Mercury. Then you have Venus. Take a look at this one. You have got Mercury. Next is Venus, Earth, Mars, Jupiter, Saturn, Uranus, and then Neptune. And after that, the dwarf planet, that is Pluto, which we no longer include, by the way. Okay, let's talk about all of them one by one. Okay, first talking about, I think we should be first talking about the sun as well. Okay, now let's talk a little bit about the sun, right? So sun is basically a star. It is the star around which the Earth and all the planets are revolving, right? Now, if you were to compare the size of the sun with millions of other stars, we see that the sun is a very medium-sized star, and it has having average brightness. It is not that bright in comparison to millions of other stars. So it's a medium-sized star. Okay, that is one thing. Further, the diameter of the sun is about 100 times the diameter of the Earth. If you were to compare the diameter of the sun, so its diameter is about 100 times more than that of the Earth. Getting it, everyone? If this were to be the diameter of the Earth, so thereby the diameter of the sun is 100 times that of the Earth. That is one interesting fact about it. Sun is extremely hot, obviously, and the temperature at the surface of the sun is about, at the surface I am saying, so at the surface it is about 6,000 degree Celsius. It is about 6,000 degrees Celsius right now. Okay. By the way, recently a satellite has went to into the surface of the sun. You might have seen that news. Anyone? NASA's Parker Solar Probe have flown to the surface of the sun to study its temperature, to study its properties. Getting it now? That's a recent thing which has happened, by the way. Okay. Further, the sun is not like a solid object. It's basically a sphere of hot gases. Okay, so if you were to think like, how long was I was inaudible? For how long I was inaudible?
For a few seconds.
Okay, okay. Yeah. So I'm saying that the sun is not a solid object. Okay, no? Basically, it's made up of hot gases. Mainly, it consists of hydrogen gases and it also contains helium gases. But more hydrogen gas is present in this in comparison to helium, right? And basically, at the center of the Earth, nuclear fusion reaction is happening. What kind of reaction is happening? Nuclear fusion is happening. Getting it, out of which huge, tremendous amount of energy is being given out in the form of heat and light. And because of this energy, the sun is shining and it would be continuously emitting huge amount of heat and light. So sun is the main source of heat and light energy for all the planets of the solar system, including our Earth and including the satellites of the planet also. Okay, getting it? That is one thing. In fact, we see that the moon is reflecting the rays of light that falls onto it. So thereby moon is visible, but the Earth is also visible from the space now, because Earth is also reflecting some amount of the light that falls on it. And in fact, all the other planets are reflecting the rays of light that falls on it. So hence, they are also visible, but not all of them are visible because they are very, very far away from Earth. That is one thing. Let's talk about the different planets. So the different planets in the order are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Out of these, Mercury is the smallest planet, Jupiter is the biggest, and Neptune is the farthest from the sun. Getting it? Also, keep this in mind that all the planets, they don't have light of their own. They shine basically because they would be reflecting the light of the sun which falls on them. Okay, so the planets are shining because of the reflection of light that occurs from them. That is one thing. Okay. Now, a planet can be made up out of rocks, metals, or could be made up of gases also. Getting it now? So the first four planets in the order, they are rocky planets. Mercury, Venus, Earth, and Mars, which are much nearer to the sun. They are called as rocky planets also. Getting it, everyone? So
Yeah.
they
Yes.
are rocky planets. Plus, we also them as the inner planets because they are nearer to the Earth. Sorry, nearer to the sun. So they are also called as the inner planets. Then the the other four planets that is left here. So they are comparatively not that dense. They are not made up of rocks. Okay. So we see that they are called as outer planets and also called as the gaseous planets. Getting it now? So these are the giant planets. They are very, very big planets. Okay. So the first four outer planets are respectively Jupiter, Saturn, Uranus, and Neptune. So they are basically giants, also being called as outer planets here. Let's continue with the very first planet now, that is the Mercury. So Mercury is obviously out of all the planets, it is closest to the sun, right? It's the planet which is nearest to the sun, basically. I will be now writing only the bullet points. It will not be possible to write all the explanation. So try to follow up with what I'm trying to say. Listen to what I'm saying. Okay. So Mercury is the smallest planet out of all the solar system, right? And the planet Mercury has a rocky surface which is covered with different craters on it. Different craters are there on the Mercury also. That is one thing. Okay. Also, Mercury, we see it, since it is very close to the sun, so it is hidden by the sun's glare, hidden by the sun's light. So it is very difficult to see. Okay, now, so it is difficult to see because since it is very close to the sun, so because of the sun's glare, it is very difficult. But however, it is visible just before the sunrise or the sunset. Okay, near the horizon, it will be visible just before the sunrise or after, or just after the sunset. Okay, so planet Mercury can be seen only at those planets where trees and other buildings do not obstruct the view of the horizon. Only, I mean, it's not planet, but only on those places where the trees and the buildings will not be obstructing the view of the horizon. Getting it, everyone? That is one thing. So Mercury, like when planet Mercury is visible just before the sunrise in the morning, so we call that as morning star. Getting it, everyone? So we call it as morning star. And when it is visible just after sunset in the evening, so it is called as an evening star at that time. Getting it, everyone, so far? Right? So it can be either seen as a morning star in the eastern sky just before sunrise. In which sky I'm saying? In the eastern sky. So it can be seen as the morning star. It can be seen as the morning star in the eastern sky, while it can be seen as the evening star just before, um, just after sunset, I mean to say. So it can be seen as the evening star in the western sky, just after the sunset. That is one thing. Okay. Hope you guys are getting it so far. Okay. Now, planet Mercury also shows different phases like the moon. It also shows different phases like the moon because the Mercury lies inside the Earth's orbit. So Mercury revolves around the sun. Its sunlit surface is visible in varying amount from the Earth. Okay, but uh, it is not visible, usually visible from the Earth because of the sun's glare. Also, there is no life known to exist on planet Mercury because it is extremely hot and has no amount of water on it. Also, it also has no atmosphere to prevent the deadly ultraviolet radiation from the sun that reaches on it. Another fact about the Mercury is that it has got no satellite. So, what are the facts we have learned so far about the Mercury? It is extremely hot. It has got no satellite. Plus, it has no atmosphere to protect the harmful ultraviolet rays of light that falls in. Plus, it also forms phases just like the moon. That is one thing. Okay. Now, since it is closest to the sun, so thereby we observe that it will take just 88 days to do revolution around the sun. So, what is the revolution period of this? That is just 88 days. Getting it, Ramiz, Vaiga, and everyone. And
Yes,
talking
sir.
about the rotation, so time taken by the Mercury to do rotation is about 58 days. That's 58 days. Getting back to the next planet. After Mercury, you have got which planet?
Venus.
Venus. Okay. Let me first write about the rotation and revolution first. So the time period taken for it to do rotation is about 243 days. About the revolution, so it takes about 225 days. Okay. 225 days to do revolution around the sun. That should be clear so far. Okay. Okay. Also, it does not have any satellites or moons. Okay, no. So just like the Mercury, it also have no satellites. It also does not have any satellites. That is one thing. So it's the second planet from the sun, and it's the planet closest to the Earth, right? And the rotation of Venus on its axis is very unusual because it rotates from east to west, whereas Earth rotates from, yes, west to east. No, so the direction of the rotation is very unusual. So it east to rotates from east to west. Keep that thing in mind. So that is an exception. So because of this, you will observe that the sun would be rising in the west and setting in the east on the Venus. Getting it? So what will happen if sun is so when it will explode now, Vaiga, so it will basically go to the supernova stage. Through the end of its lifespan, when any star would be exploding, so it enters the supernova stage. Okay, you can Google the pictures of the supernova and you can look at how it will look. Okay. Getting back to this, so rotation, it will be on east to west. Thereby, the sun will be appearing to rise in the opposite. No, where will it appear? Yes, sun would be rising in the west. No, and would be setting in the east. Why? Because rotation, the direction of rotation is opposite. That is one thing. Plus, the Venus has got atmosphere. Okay, and it has a very dense atmosphere, right? And the atmosphere of the Venus usually consists of carbon dioxide gas in it. Keep that in mind. And Venus is the biggest planet in the night, brightest planet in the night sky. In the night sky, it is the brightest planet. Okay. So in fact, we see that the planet Venus is the brightest object in the night sky except the moon. If you were to talk about comparison of the planets, so we can easily recognize the planet Venus in the night sky because of its brightness, and the planet Venus appears very bright because it is cloudy. Its cloudy atmosphere reflects 75% of the light which it receives from the sun. So out of all the planets, which one is the brightest planet? That's Venus. Why it is happening? Because the cloudy atmosphere would be reflecting the rays of light that falls on it. Hence, it is very much bright. Okay. Another fact about this is that though Mercury is the nearest planet to the sun, but Mercury is not the hottest. So the Venus is the hottest planet. Getting it, guys? So Venus is also the hottest planet. Okay. Now see, this planet is also called as a morning star or an evening star. Just we have learned about the Mercury. So in this context, also we see that this is also called as a morning star or an evening star, as you guys can see here. Getting it now? So it is also called as morning star or the evening star. This is where the Venus is present here, right? So you can look it at the sunset or the sunrise. That is one thing. So just like we have learned about that Mercury also shows different phases. So Venus also shows different phases. Keep that thing in mind. So that also shows different phases, just like the Mercury will be. Okay. Does it have any satellite? So it does not have any satellite. Okay, now hope that much should have been clear. Next, talking about the planet on which we live, that is the Earth. So Earth is the third planet from the sun. Okay. And it lies between the two planets, that's just Mercury and Venus. So Earth is lying between Mercury and Venus. It is roughly spherical in shape, and when it is viewed from the outer space, the Earth appears to be blue and green, like a blue and green ball, because of reflection of sunlight from water and land on its surface. In fact, it's the only planet, as we know, has got life on Earth, right? That is one thing. What is the reason that life exists on Earth only? The first reason is that it is it is at a proper distance from the sun, right? So because of the distance of the Earth from the sun and the size of the Earth, right? So we see that the Earth has got a very correct temperature, a temperature range that is required for life to exist. Plus, the size of the Earth is such that it has sufficient gravitational field to hold on to its atmosphere, to hold on to an atmosphere of many gases like you have oxygen, nitrogen, carbon dioxide, helium, neon, etc. Getting it, and all these gases are very much needed for survival of life on Earth, right? So Earth is the third planet from the sun. Okay. Rotation, everyone knows that is 24 hours, and revolution, everyone knows that is 365 and one fourth of a day, basically, right? That is the case. Earth has got its own natural satellite. That's the moon. Okay. So these are some of the facts about this. Plus, Earth has like atmosphere, unlike some of the other planets which does not have atmosphere. Like Venus has, but some of the planet does not have atmosphere. So this has got an atmosphere. It has large quantity of water in it. Obviously, it has a suitable range of temperature. So temperature is very much suitable for life to sustain on Earth. Getting it? Plus, it has a protective blanket of ozone layer. So ozone layer is present on the surface, in the atmosphere, that is in the stratosphere particularly. Further, Earth would be rotating on an imaginary axis which passes through the north and south pole of the Earth, basically, right? Also, if you were to look at the axis of the Earth, so the axis of rotation of Earth is slightly tilted, okay, with respect to the plane of its orbit. Like this is the plane of the orbit here. So to this, it is slightly tilted, and it is tilted at an angle of 23.5 degree, right now. So to this perpendicular plane, the axis of the Earth is tilted 23.5 degree. Getting it now? That is one thing. So it is rotating on its axis in the tilted position, and it is also revolving around the sun in the same tilted position throughout the course of 365 and 1/4 of a day, right? Also, an important consequence of the rotation of Earth on its axis is basically because of its rotation, it causes day and night, right? That is one thing. Okay. Hope you guys are able to understand this much. Okay. Also, like another important consequence of the motion of tilted Earth around the sun is that it causes different seasons on Earth. So, because of the rotation, as you guys would be aware, like day and night phenomena is occurring, and because of revolution, change in season is occurring. Hope that much should have been clear. Okay. Next, we come to the red planet, that is Mars. Okay. So it's the fourth planet from the sun, and it is the first planet beyond the Earth. Fourth planet from the sun and first planet beyond the Earth. We are calling this as red planet because its surface appears red in color, and it is used to like the red color of the Mars is used to distinguish it from other planets of the solar system. It is visible from the Earth for most part of the year, and also note down that this planet does not appear as morning star or evening star unless unlike in the case of Mercury and Venus, they appear as morning and evening star, but the Mars does not appear as morning and evening star. Keep that in mind. Okay. Now, out of all the planets, Mars is most like the Earth. That's why you would have been hearing this thing like there have been various plans about colonizing the Mars. Right now, there have been various plans about colonizing the Mars, but not other planets, huh? Because Mars is very much like Earth. Getting it? Hope you guys are able to understand this. Okay.
Yes.
Plus, Mars has a very thin atmosphere in comparison to the Earth. It has an atmosphere, but the atmosphere is very thin. So it's the fourth planet. It has got a thin atmosphere. Plus, let us learn like why it is red. So what do you guys think? Why it is being called as the red planet? Now, why we are referring to Mars as the red planet? Because the surface of the planet contains iron oxide or basically rust in it. Getting it? So surface of the Mars contains iron oxide, which is red in color. Hence, the whole planet looks red in color. The rocks, the soils, and everything here has oxidized, and it basically looks red in color. Hope that much should have been clear. Okay. Now the thin atmosphere that this planet has, it namely contains gases like carbon dioxide. Okay. And it contains some nitrogen, some oxygen, and some amount of water vapor is also present in it. Getting it? So scientists say that this planet contains all the necessary ingredients for life to exist. Getting it? But it is having very less amount of oxygen and water that is not sufficient to provide support to any form of life. Even it is not sufficient to provide support to primitive life, very simple form of life. That is one thing. Talking about the time taken by this for revolution and rotation, it is as follows. So the Mars would be taking about 687 days for revolution, and it takes the same period, that is 24 hours, roughly 24 hours and 37 minutes is taken to do rotation. So in these manners, it is quite similar to the planet Earth. Talking about the biggest planet out of all, that is the Jupiter. That is at the fifth position from the sun. Talking about the time it takes for revolution, it is about 11 and 3/4 of a year. 11 years and 3/4 of a year. Talking about the rotation that it takes, so it is very small. It is very short period of time. That is just 9 hours of time. is taken for this planet to do rotation. Okay. Uh, it's the fifth planet, right? And it is almost twice as large as rest of the planets all put together. Keep this thing in mind. Like if you were to put all the planets together, this Jupiter will still be twice all the planets. Okay. Plus the mass of the Jupiter is also more than the combined mass of all the other planets. In fact, if you were to compare the diameter of the Earth and that of the Jupiter, so the diameter of the Jupiter is about 11 times that of the diameter of the Earth given here. Also, it is said that like we can put about 1300 Earths inside the Jupiter. How many? It is so big that 1300 Earths can be put inside the Jupiter. That is one thing. Okay. Also, being very far away from the sun, Jupiter receives very less amount of heat and light from the sun as compared to other planets, right? But still, it appears to be a very bright object in the night sky. And it is because of the fact that it has a very thick cloudy atmosphere, which would be reflecting the rays of most sunlight that falls on it. So we can easily recognize the Jupiter as it appears quite bright in the sky. Okay, that is one thing. Plus, its speed of rotation on axis is very fast. So that is, it just takes 9 hours to do rotation. Okay. Plus, it is a gaseous planet, and the gases that is usually contained in it is hydrogen and helium. These are the gases present in it. And it contains about 67 satellites. It has how many moons? So 67 moons are there. Okay, no? Plus, you can also see some of the faint rings around it. Okay, so if you were to observe this Jupiter planet with the help of a telescope, we can see that they are rings around it also. So these are the faint rings present around it. That's all about Jupiter. Now, between the Jupiter and the Mars, you will see this belt of asteroids that is also doing revolution around the sun. So asteroids are also present over here. So that's the asteroid belt which is present between the Mars and the Jupiter. Keep that thing in mind. Okay. This is a video regarding the Jupiter. We don't have time, otherwise I would have played this. Just 1 minute. Next, after that, we have this Saturn planet. Okay. So it's the sixth planet from the sun. It is smaller in size and mass than the Jupiter, obviously. But after the Jupiter, it's the second biggest planet of the solar system. So sixth planet, second biggest out of all the planet. Okay. And that is also made up of hydrogen and helium gases, respectively. Okay. That is one thing. A very interesting fact about the Saturn is that it is the least dense planet among all the planets. Okay, no? So its density is very least. So density, least density. That is one thing. Also, you will observe that it has got distinct sets of rings that is visible around it, and it's the only planet with a very well developed like circles that is encircling around it. Okay, now these rings are very well developed that is encircling around it. Okay, and these rings that you see, they are basically made up of tiny particles that are orbiting around the Saturn, just like a mini version of the satellites, small kind of satellites. Although the rings of satellites of the Saturn cannot be seen with the naked eyes, but with the help of a telescope you can observe it. Okay, that is one thing. Hope you guys are getting it so far. And being very far off from the sun, it is extremely cold. Okay, na? So no life can exist on it. Plus, it has got about 62 satellites are there on the Saturn. How many? 62 satellites are there. And how many Jupiter had? How many satellites did Jupiter had? Yes,
62. 67.
exactly. Talking about rotation and revolution. So the time taken by this to do rotation is about 29 and a half years. Sorry, revolution, I mean to say 29 and a half years. And about the rotation, it takes about just 10 hours to do rotation. By the way, just one correction, for in the case of the Jupiter, it is about 9 hours and 50 minutes. Okay, now 9 hours and 50 minutes is the time taken for it to do rotation. Okay, so that is about this. Okay, do we have time left? I think no. What's the time? Okay, you guys just wait for 1-2 more minutes. Okay, now wait for a few minutes till the other batch starts. After that, we have got the Uranus. Okay, so the one that you see over here, that's the Uranus. Okay, let's talk about the rotation and revolution first. So the time taken by this for doing a rotation is about 10 hours and 49 minutes. Notice how as the size of the planet is increasing, the time taken by it to rotation is decreasing. Getting it, guys? And the revolution is about 84 years. Getting it? It takes about 84 years to do revolution, and it is quite obvious since it is very far from the sun, so it is going to take longer period of time. In the case of the Neptune, you will see that it will take about 160, 165 years to do a revolution. Getting it, guys? Talking about the Uranus, it's the seventh planet as we're discussing here. It's a seventh planet from the sun, and it can only be seen with the help of a large telescope. In fact, it is said that it was the first planet to have been discovered with the help of telescope. Although the diameter of Uranus is about 4 times that of the Earth, it appears as a small disk through our telescope. It appears as a very small size planet, but it's big. Okay. Further, it's the third biggest planet of the solar system after Jupiter and Saturn. And like Venus, Uranus also rotates on its axis from the east to west. So another important thing is that it follows the same direction as the Venus would be following. That is one thing. The most remarkable feature of this planet is that it's highly tilted. The axis of rotation of this planet is highly tilted. So over here, you can take a look at the axis of tiltation of different planets and look at the axis of tiltation of Uranus. It's about 98 degree. Getting it? Earth is just 23 and a half, but Uranus it is 98 and 98 degree. Okay, so axis is highly tilted. That is about 98 degree. Getting it? Like this is the perpendicular line over here. To this, it is tilted at about 98 degrees. So that is some of the interesting things about it. Okay, now also talking about the number of satellites. So it has about 27 satellites. It has 27 moons basically. Sometimes this has got some rings around it also. Okay, now as you guys can see, some of the rings are also present in it. Then we come to this last planet, that is the Neptune, that is the eighth planet from the solar system, and it lies beyond Uranus, outermost planet of the solar system, the most distant planet we can say. Okay, also very farthest from the sun, obviously. So it's the second planet which was discovered with the help of the telescope. The first planet was Uranus. This is the second planet to have been discovered with the help of the telescope. Keep that in mind. Getting it? Talking about the satellite, it has got 14 satellites in total. Okay, it has got about 14 satellites in total. Neptune, it is mainly made up of liquid and frozen hydrogen and helium gas. Keep that in mind. Mainly made up of liquid hydrogen and helium gas in it. Okay, so it is also very cold planet. It is extremely cold planet. So thereby life cannot thrive on this. Getting it so far? That is one thing. Also talking about the time taken by it for a revolution. So that is about 165 years. So to do revolution around the sun, it takes 165 years. And to do rotation, it takes a period of just 16 hours and 3 minutes. Okay, no? So these are some of the interesting facts about the planets. Okay, we still are left with some of the things. Okay, so to do question answers, okay, Harim, you can leave. Others can also leave. Just listen to me 1 minute.